Let's talk chemistry with Pastor Dan. We're going to practice some of those abundance problems. I'm going to give you two sets. This will be 2 different days. So you can do the one, take a break, come back, do the other day. So here's the first set. We have a few protons, neutrons, electrons, and all we're doing here is number atomic mass and our protons and neutrons. Atomic number is just number of protons. So if you review back, so we have calcium, phosphorus, nitrogen, iron, and thorium. And then we have 1, 2, 3, 4, 5, 6 problems for you to do in abundance. Three of these are finding the atomic mass based off the abundance, so you're going to get a percentage. The last 3 you're going to use to find the percentages. Now remember, all you have to do is get a periodic chart and identify them that way. All right, so let's go through and do one of each of those to make sure that we have them understood pretty well. So let's do this one right here. I have 200U at 71.22%. I have 202U at 10.33%. I have 204U at 8.44%. 206U at 10.01%. Remember, my numbers should range then between 200 206. Shouldn't be lower than 200U, shouldn't be more than 206U. So what we're going to do is take the first atomic mass and make that percentage a decimal. So 200 times 0.7122. Then do the second one. 202 times 0.1033. Now this one gets people. I have had students make so many mistakes with this because they move it one and not 2 places. So for the next 2, we should get 204U times 0.0844, and then 206U times 0.1001. We multiply through. Now remember sig figs. These numbers are exact numbers, so it's significant. I have 4 sig figs, 4 sig figs, 3 sig figs, 4 sig figs. So for the first one, you multiply it through, you should get 142.4U. Second one, multiply it through 4 sig figs, we get 20.87U. Now the next 2 do as well. Take 204 times 0.0844, get the number, write it down. Then take 206 times 0.1001, get the number, write it down. The answers that I have is 17.22U and 20.62U. Then we're going to add them all together. When we do, we get 201.1, and that is 1. That is between 200 and 206. Now remember, we got to remember this is addition, sig fig rule for addition, last row column. Last row column is going to be that 10th place, so that 0.4, 0.8, 0.2, 0.6. So that's going to be right there, that 1. So my answer here is going to be 201.1U. All right, let's try the other percentage now. I have 2 forms of gallium, gallium 71, gallium 68. Now there's actually more than that, but just to keep it where we can do the work, we're going to make 2. So we take 71 atomic mass. We don't know the percentage, so that's X. We then take the second isotope, which is 68. Don't know which percentage, but we don't want to use Y. So therefore we take all of it minus X, or 1 minus X. And that's going to equal 69.723. Again, I got that from a periodic chart. Multiply through. If I take 71 times X plus 68 times 1 minus X, I get 71X plus 68 minus 68X, because distributive property. 68 times 1 is 68. 68 times minus X is minus 68X. Now combine like terms. I have 71X and minus 68X. Those are both X's. 71 minus 68, and I get 3X plus 68. Now I want to move that 68 right here to the other side, so I'm going to subtract 68 from both sides. If I subtract 68 from both sides, I get 3X is equal to 1.723. I want to get X by itself now. I'm going to divide both sides by 3. If I divide both sides by 3, I get X equal to 0.5743. Now, when I do this, remember that is for 71. 71U is X, so therefore that's 57.43%. How about the other value then? For 68, remember it's 1 minus X, so that's 1 minus 0.5743, and the answer there is 42.4257 as a decimal. That would, a percentage rather, be 42.57%. Those are our answers. There we go. All right, I do have a second practice you do, so you can either do this on the same day, or we can do this on another day. So here's my second set of practice. Again, we're doing the same kind of thing here. We're doing starting with atomic masses, protons, neutrons, electrons, and then we're doing 3 percentage atomic masses and 3 percentages. So you can go through and work those through and get those done. All right, good, good, good. All right, so here's our answers. Answer the first set. So we end up with 20, 20, 20 because 40 minus 20, that's easy. And 31 minus 15, that's 16. Number of protons and the number of electrons are always the same, atomic number. And then we have our answers here for these sets right there. There we go. So you can see what those are. And let's do this one here then. There's our answers for the top set there. And there's our answers for the bottom set. All right. Hopefully that wasn't too bad. We are going to go into next concept of matter next after this. And then we're going to practice that, do a couple of reviews. And the next test is coming up. We're going to keep it shorter because the next concept we're talking about is just electrons. And that's going to take a little bit of math, and I want to make sure I don't cause confusion, have too much overlap. We'll make a short section, knock it through, be good. All right, take care. Bye.